All right, number 19. The thing that I hope you notice about number 19, first of all, it's a binomial, so it's one of those three that we've talked about. And we have two perfect squares. So when we have this, we use the a squared minus b squared equals a plus b times a minus b, okay? So this just becomes 4y minus 7x times 4y plus 7x. And I know they're not in alphabetical order, but they're not in alphabetical order there either. So you're in pretty good shape. Okay, over here, I am using, hang on a second. I'm using a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So I'm just using this in this formula. So this is b cubed plus 6 cubed, all right? So b cubed plus 6 cubed, a cubed plus b cubed. So this becomes b plus 6 times b squared, so I have that one squared. 6 squared is 36, and then when you multiply the two together, you get what's on the inside, which is 6b. Okay, and I have to have one negative, so that goes there, and that one goes there. All right, this one is also a binomial, but one thing I hope you notice is that I have an x cubed here, and that gives it away what I'm going to do. But 64 is not only a perfect square, but it's a perfect cube. So don't let that confuse you. Don't think that that's a perfect, well, it is a perfect square, but we're using it as a perfect cube. So this is going to be 4x cubed minus 5 cubed. And so using my formula, I have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. All right, so this becomes 4x minus 5, okay? Square the first one, square the second one, okay? And in the middle, I multiply the two, so I've got 20x. And since I already have my negative, that's going to be a positive, and that's going to be a positive. All right, last one. This one has 4 terms. So if you've got something with 4 terms, you know that you can divide it into 2 groups, which means you use grouping to factor it. So, okay, I'm going to divide it down my little line there. I can pull a z squared out, and I'm left with z minus 5. Over here, I can pull out a negative 9, and I'm left with z minus 5. So I've got z minus 5 times z squared minus 9. But here's the thing, I'm not done, because I have the difference, or subtracting, 2 perfect squares. So I can take this one step further. So that's z minus 5 times z minus 3 times z plus 3. Okay, moving on. Recreate Pascal's triangle up to 9 rows, or when n equals 8. Okay, this one I threw in there just to help you remember how to do Pascal's triangle. And remember, we start with a 0th row, that's my 1. Then I just go down from there. And remember, I'm adding the 2 above it to get the 1 below. So 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So I'm on the 5th row. This is 0th row. 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, 35, 21, 7, and 1. And finally, my 8th row, well, it's kind of my 9th row, but when n is 8, I have 1, 8, 28, 56, 70, 56, 28, 8, and 1. Okay, so that's the answer to that problem. Hopefully that one wasn't too hard. Okay. All right. Show that the binomial is a factor of the polynomial, then factor completely. So we talked about this a little bit. Well, I talked about this in other videos. And so what we need to do is use a synthetic division. And if my remainder is 0, it means that it is a factor. So the first step is to show that my remainder is 0. So I have x plus 1, so I'm going to have a minus 1 here. And this does not have an x squared term, so I'm going to throw that in. So I have 1, 0, negative 13, and negative 12. I didn't give myself a ton of room on this one. Okay, so we have 1. This is negative 1. We add that. This gives me a positive 1, negative 12. Negative 1 times 12 is 12. And here's the first part. It shows that my remainder is 0. So x plus 1 is a factor of this polynomial. And now what I have left is x squared minus x minus 12. And when I factor that, I get x minus 4 times x plus 3, because negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. And don't forget, this is important. This is not this polynomial completely factored. I have to remember that I have one more factor there. Okay, so make sure that that's included. Okay, I'm going to continue then in the next video.